y equals 2x plus 5 times x plus 4 all over x minus 3. Let's have a go at this. Let's expand the bracket first. So we've got 2x squared. Then we've got 8x plus 5x is 13x's. And then lastly we've got 5 times 4 is 20. That's all over x minus 3. So that's equal to then 2x x. Now that will give us our 2x squared. Now we need a minus 3 here. So that will give us 2x squared, which is what we want. Then we've got minus 6. We want 13, so we need a plus a 19x. Plus 20. So we've still got the same. And then we've got that. Now let's carry on with this process then. We've got 2x here. X minus 3. Then we've got plus 19. Let's put the x minus 3 in a bracket there. That will give us 19x's, but minus 57, and we've got 20. So we need a plus 77 in here, all over x minus 3. Let's just double check that now. So we get our 2x squared, which is what we wanted. Minus 6x plus 19x gives us our 13x. And then the numbers, minus 57 plus 77 gives 20. So now we can split the fraction up into the 3 parts. The first part we'll just leave 2x. The middle part here we'll just leave 19. And then the latter part, the plus 77, is just left with the x minus 3 underneath. So that's what we've got then. So here's our line, our asymptote. So 2x plus 19, so it's going to intercept at 19, have gradient 2. So let's draw it in, like so. And the line continues down here. Gradient 2, intercept 19. Supposed to be a straight line, of course. Now the other asymptote value is at 3, so let's mark that in on the x-axis. We can use any scale we like. So I'll just do it here. I've come through the actual question, down through here. Now let's have a little look then. As x tends to large, this is a plus, so x gets large. This is a plus a small fraction to this line here, so it's from above. As x gets large negative, this denominator is large negative, making this fraction small negative, so it comes from below to this line here, because you're just adding a small negative number to this value. So it tends to this line, doesn't it, for large negative. Now the other asymptote, we think it's going to come up from here and go down from here. Let's just confirm that. Just under 3 then. Let's put that in. Just under 3 on this. This will be negative underneath, small, making this fraction large negative. Large negative for just under 3. So it's going to shoot down there. Just over 3, this is small positive, making the fraction large positive. So it's going to shoot up to infinity here, up here, isn't it? So, sorry, apologies for drawing the curve over the question, but I'm going to do that anyway. So it's going to come down here, turn and go there. There's going to be a minimum here. And what value is it at 0? Just out of interest. It's going to be 20 over minus 3. So we could put that in. Now it's either going to peak here before or go through and peak either there or just after. So I'm going to, because of the way it's proportioned, I'm going to take a hazard a guess that the maximum is actually reached over there somewhere and go down. But that's not crucial in terms of sketching the curve, because this would be an awful lot of work to work out precisely whereabouts this maximum value is here, and also this minimum is here. So for the purposes of the sketch and the characteristics of the curve, this will suffice. So let's have a look at the actual sketch then. So I'll just tap it in here, it won't take a moment to do. So it's 2x plus 5, 2x plus 5 in our widget tool, x plus 4, brackets, divided by bracket, x minus 3. So I've put all the brackets that are needed. And from minus 10 to 10, say, we can check the output's okay. There's the plot, that's correctly entered. And we've got our maximum, which is where we thought it might be, on the negative side. And then turning back down. So again, you probably want, let's do it from minus 100 to 100, so that we can see it illustrate the other asymptote illustrated quite well then. Let's just have a quick look at that to make sure we're on the right tracks. Yeah, there we go. There's the asymptote there.